So this video is going to go over the calculations that you need to do for the titration lab. So I have it broken down into two different steps. Do realize that these numbers aren't necessarily what you're going to see in the lab, but it's a way for you to kind of mimic the same calculation. So day one, so if you want to write down day one, we are what we call standardizing the NaOH. And what I mean by that is we are just trying to find the molarity of the NaOH. So the molarity of the NaOH is what we are going for here in this problem. So it is what I call a three-step process. I am going to take the volume and the molarity of the HCl, which I know 2 bits of information on. I'm going to then convert it to the moles of NaOH and then find the molarity. So moles of HCl, I'm going to take the molarity, which is 0.2 moles over liters. So remember, molarity is moles over liters. And I'm going to multiply it by the volume in liters. So 50 milliliters, I'm going to move that decimal 3 over. So I'm going to multiply it by 0.05 liters. Okay, so I just converted the 50 milliliters to liters. So 0.05 times 0.2. The liters will then cancel each other. So again, I'm not going to set this up as a proportion because it's a little easier just to do it this way. So I end up with 0.01 moles of HCl. So I'm going to write it here on the line just so I could find that bit of information. Now, the nice thing about this titration we're doing, everything is 1 to 1. So I have 1 mole of hydrochloric acid to 1 mole of NaOH. So all I have to do is I have to say 1 mole of HCl equals 1 mole of NaOH. Also note, I could just set this as a ratio. 0.01 mole of HCl is how many moles of NaOH, but again, it looks pretty obvious that I have a 1-to-1 relationship here, so I don't really need to do this setup, but that is how you do the middle step. You always are using the balanced chemical equation. So this is 0.01 mole of NaOH. And then finally, the molarity of NaOH. I still have the volume, and this is the volume that I had to add in order to get to my endpoint until it turned pink. So again, molarity is moles over liters. Okay, so I have moles of NaOH in the previous step, so 0.01 mole. And I have this, but I got to convert it to liters. So I move the decimal 3 over, so I have 0.0411 liters. And when you divide those two numbers, you get 0.24 big M, and I have 2 sig figs here, so I'm going to write it as 0.24 molarity, 0.24 molarity. So why that's so important is because this is day 2. This is what you're going to be titrating on your own. Everybody's going to get their own acid today, or when you do this step. So the one thing that you do need to understand is this is a monoprotic acid, meaning you have 1 H. So it doesn't matter what the acid is, just know that there's only 1 H. So everything is 1 to 1. And we did that on purpose so that we don't have to worry about what the formula actually is. So we are going to use the molarity from day 1 and put it right here. So I'm going to write 0.24 molarity because that is the same NaOH I'm going to use on day 2, the same NaOH I'm using on day 2. So I am going to have a little different calculations because I'm trying to find the unknown acid, and specifically its molar mass, so capital M, capital M. So a little different calculation than we typically do on a titration. But moles of NaOH, I could find that. And the reason I could find the moles of NaOH is because I have a volume that I added in order to get it to pink, and I have a concentration. So always know if you have a molarity, you could always multiply it by the liters, 0.0304, to find the number of moles, okay? Whether it is the base or the acid, just know that that calculation is pretty reliable. So 0.0073 moles of NaOH is how much I added in order to get it to my endpoint. Okay, so I could put 0.0073 moles on that line. Again, nice thing about this is day 1 and day 2, we are talking a 1-to-1 relationship. So every mole of acid is equal to 1 mole of the NaOH. So this one, I think it's much more appropriate to put the relationship because there really is no math that is needed. So 0.0073 moles is going to be your moles of acid. So finally, this is the weird step. I have grams here, okay? The acid we're using is not, we're not using a pipette because it is a solid. And since it's a solid, I have a little different last step than you saw on day 1 when you were finding the molarity. So instead, I have grams and I know the moles. Well, molar mass, okay, is grams over moles. Okay, from a long time ago when we did a lot of stoichiometry. So what we're doing here is we're going to take the grams. So I put 0.56 grams and I divide it by the moles, 0.0073 moles. Okay, so how much grams did you put into the flask and dilute it down with water? And then how many moles of the base did you essentially add in order to neutralize it, since we know it's 1 to 1? So if you divide those two, you get the answer 77 grams per mole. So that is a molar mass. It is not something on the periodic table. It is not HCl. It's not HNO3. It's a completely different organic acid that we're not going to talk about. Instead, we're just going to do it for the calculations. So that is how day 1 is finding out the molarity of the NaOH, and day 2 is finding, with that molarity of the NaOH, essentially what is my molar mass of my unknown acid.